Welcome back to another episode in my proof series where I basically show you why certain things happen in mathematics. Right now we're doing y as the limit of h approaches 0, 1 minus cos h over h equals 0. This comes from a previous episode when I showed why when you derive sine you get cos. And this was one of the questions that come up in it. And along with the episode that I did before this, that was why sine h over h equals 1, because we're going to need that for this episode. And I basically showed why they happen, and now it's time to show you why this happened, because I couldn't do it in the sine cos video because it would have made it too long, and I didn't want it to go too long. But on that note, anyway, I will prove why and show you how it's done. So I'm going to write out the limit as h approaches 0 of 1 minus cosine of h over h. Okay, now when I see 1 minus cosine of h, that looks very similar to a trig identity. And I've got that over here. I've got this rule, which is sine h over h equals 1, because we're going to need that. But I've also got this trig identity. It has sine squared, cos squared, and it equals 1. When you add these two, you get 1. Now that looks very similar. Because we have a 1 minus cosine, it's very similar, but different, because the cos isn't squared and we haven't got a sine squared. But if we rearrange it, we get sine squared equals 1 minus cosine squared theta. Now, because 1 minus cosine squared theta looks very similar to 1 minus cosine of h, we'll see if we can turn it into that. So I'm going to multiply the 1 minus cosine of h over h by the conjugate of 1 minus cosine h. And I'll do that over here. 1 minus cosine of h over h multiplied by 1 plus cosine of h over 1 plus cosine of h. Now that we've got that, what I'm going to do is expand these brackets out. Limit as h approaches 0. Okay, I'm going to rewrite it so it looks, if you're not following, or you're not able to follow, this should make it easier. Because anyone who has done grade 11 mathematics should know how to expand brackets. Or it'd be wise to learn that before learning this. Anyway, that's what we're going to be doing. So, what I'm going to do is expand these brackets. I'm going to try and bring it up so we continue it on. Okay, limit as h approaches 0. I'm going to expand this out. 1 times 1, 1 squared. 1 times cosine h plus cosine of h. Negative cosine multiplied by 1 minus cosine of h. And then negative cosine of h multiplied by cosine of h equals negative cosine squared of h. All over. I'm just going to leave the bottom like it is. H bracket 1 plus cosine h, because we're going to leave it that way for later. Now that we've got that, we can do some cancelling. Because we've got a plus cosine of h and a minus cosine of h, we cancel these out, rewrite it. We always write the limit as h approaches 0. Then we're left with 1 squared minus cosine of squared plus h, minus 1 squared minus cosine squared h, all over h bracket 1 plus cosine of h. Okay, now that is very similar to that. In fact, it's actually the exact same as that, and I'll show you why. What is 1 times 1? It's 1. So we don't really need this because you can have 1 to the power of 3, 1 to the power of 4, 1 to the power of 2, and the answer will still be 1. So technically, we've got that. We've got 1 minus cosine squared. We've got 1 minus cosine squared. Therefore, we can substitute sine squared in for this. Substitute sine squared in for this. And that's what we're going to do. So, the limit as h approaches 0 is going to look like sine squared h over h bracket 1 plus cosine h. Okay. Now what we're going to do is we're going to split. We're going to split the fraction. I'm going to grab this piece of paper here and just show you first what I'm about to do. So if I were to have, if I was to have x over 1 and then multiply that by 2 over x, I'll just do 2 over x. I won't simplify it. This is just an example. If I were to multiply this together, it would look like 2x over x. Now that is because I'm multiplying the 1 by the x, and then I'm multiplying the x by the 2. So I'm multiplying the top by the top and the bottom by the bottom. So if I wanted to, I could essentially split that to look like this. So I could split the 2x from one side and have the x over 1 to the other. I could reverse it. So that's what I'm going to do here. Just like I have a sine squared h over a h multiplied by 1 plus cos h, I'm going to split it. And you'll see why I did that. So if I split it and have sine h over h multiplied by sine h over 1 plus cosine of h, now you can see that sine h over h, we already know that as being 1 when as the limit as h approaches 0. So that's good. That's what we wanted. We wanted to isolate that and isolate this. Okay. Now, because there's a multiplication symbol in the middle, we'll find the limit of each separate side and have them multiplied together. So if I rewrite this as h approaches 0, we're finding the limit of each one separately. See, just like that, with a multiplication in the middle. Because there's a multiplication in the middle, I am going to find the limit of each side separately. Now we know, but I'm then multiply it after. So I'll write the multiplication sign there, already. What's this side? The limit of h as it approaches 0. We already know that to be 1. So it's just 1. And over here, the limit as h approaches 0. So sine h, if we were to think of it at 0, sine of 0 is 0 over 1 plus cos h. If h was 0, cos h would be 1, so it would be 1 plus 1, 2. You see here, 1 multiplied by 0 over 2. Well, firstly, that's 1 multiplied by 0, because 0 over 2 is 0. So you're left with 0. And therefore, the limit as h approaches 0 of 1 minus cosine of h over h equals 0. I hope you learnt something from this video, and if there's anything better I could do to help bring this information across to you, leave a comment, like, subscribe, but mainly I hope this helped you in some sort of way. Thanks for watching.